Hello everyone, I am Hemalatha K, working as an assistant professor in Information Science and Engineering Department in BGS College of Engineering and Technology, Mahalakshmi Layout, Bangalore. I am doing the PhD in Adichunchanagiri University under the guidance of Dr. Naveen B. My research area is blockchain technology data storage with cryptographic applications. I am coming for the few discussions before starting up the topic. Let me have a few questions for you people, guys. Can you just think how the car automatically on during the dark time? How can a smartphone can read your heart rate? And how actually the mall's door automatically opens when you enter? Do you have any idea? The answer is very simple. These are all because of sensors and the transducers in the modern application. Today we live in the world, in a smart world, from smart cars to the smart homes, from the smart cities to the automobiles, Industry 4.0. Everywhere we go, that depends upon sensors and transducer. Why this topic is very important? Because it forms the foundation for any of the topic you take it, any of the technology you take it today, IoT, robotics, AI, artificial intelligence, that means automation industry, Industry 4.0, smart cities, everywhere you go, this will be the foundation course for all the technologies. That is why we are taking up the course or the topic, that is sensors and transducers in the modern application. In today's lecture, we will be discussing on what is sensor, what are the transducer, what are the types of the sensors do we have actually, and I will be taking on this topic, I'll be taking some of the few real-time applications, and let me tell you what are the sensors behind those applications and how it works. So let's start with the topic. Firstly, I need to say you, what are sensors and the transducer? Sensor is a device that detects and senses the changes in the physical quantities around us, that is around the environment. For example, temperature, pressure, light, motion, sound, anything. So the sensor, it will sense all these environmental factors and it converts these changes into the electrical signals that will be measured or processed. This is called as a sensor. What do you mean by actuator? Actuator is a device that takes the electrical signals from the processor and converts it to the physical action, and it will reach the outside world. I am telling the three parts or the three components in the IoT. What is this actuators? What is this sensors? What is this transducer? All these are same. All these are different. Let me explain you through this diagram. Any of the physical attribute or the physical parameter in the environment, it will be reached to the sensors. This sensor, it will take the input, senses the physical parameter, and those it will be converted to the electrical signals and it will be given to the processor. The processor processes the entire electrical signals, which is in the form of zeros and ones, and according to the program what is being written, that will be processed and it will give the output to the actuators. And the actuators take those signals, take the output, and it will work according to the program. Let me take one example for sensors, actuators and transducers. See, let me take an automatic water sprinkler, what is been attached in our garden. Automatic water sprinkler, it will work on the basis of the soil moisture of the plants. So the function is, here the sensor, it will detect the moisture of the plants, and whenever the moisture level it will go below the threshold, it has to give the signal to the processor. The processor, whenever it gets the lower level than the threshold, it will give a signal to the actuator. The actuator, it will automatically sprinkle the water. Suppose the same sensor, if it is sensing the soil moisture which is above the threshold, that signal also will go to the processor, where the processor will give a signal 0 there. We reach to the actuator that means the water pump. Here the actuator is a water pump, and here the sensor is a water sensor, soil moisture sensor. So here, let me come again for the water pump. Now we got the zero signal whenever we have a proper soil moisture. So the water pump, it will be off. So depending upon the soil moisture, the sensor detects the soil moisture and gives the signal to the transducers or the actuators and through the processor. So the entire scenario of the IoT works on sensors and the actuators. Here if I can say, sensors and actuators both are transducers, but sensors will work as an input transducer where it converts temperature sensor or physical parameters into the electrical signal. Here also we are converting one form of energy to the another form of energy, because that is a transducer again. Actuator is also a transducer because it is converting electrical signal into the mechanical action, or electrical signals into the light energy, electrical signals into the sound energy. So even here the actuators is converting one form of energy to the another form of energy, and that is why I am saying both sensors and transducers are same. But sensors are the input transducer which will work at the input side, and actuators are the output transducer which will work at the output side. This is the relationship between the sensors and actuators as transducer, and this is the diagram which will explain the entire relationship between sensors and the actuators as transducers. Now let me go for the next topic, that is types of the sensors. Here we have a million types of sensors, but let me take only a few types of the sensors, which are temperature sensors, pressure sensors, motion or proximity sensor, biomedical sensors, and the gas sensor. Let me come for the first type of the sensor, that is temperature sensor. We all know that temperature is the most common measured physical objective. If we take to the laboratories, we will measure the temperature. If we go for hospitals, if we go for electronic components, research labs, temperature is one of the most commonly taken measurements for any of the experiments. So what do you mean by this temperature? Which are the sensors which will be measuring the temperature? Let's go for this. Temperature is the one parameter which will measures the heatness of the environment. Temperature sensors are the devices which will sense the temperature, and it will be converted to the electrical signals. And we have two types of temperature sensors: contact and non-contact temperature sensors. Contact temperature sensors, it will be in physical contact with our body and sense the temperature and give the recording. Non-contact temperature sensor, it will just be near to that physical quantity and it will sense the temperature, sense the heat, and it will be converted to the electrical signal. Let me go for some few example what is there in the slide. First one, thermometer. Thermometer is a device used to measure the temperature of a solid, liquid, and a gas. Thermometer contains a liquid which is called as a mercury, or sometimes alcohol can also be used, in its glass tube. Whenever the liquid gets heated up, it expands inside the tube and measured according to the numbers what is being given. This is the principle behind the thermometer. The second what is being listed, that is a thermistor. The name thermistor itself has two parts inside it. One is the temperature and the other one is a resistance. As the temperature changes in the environment, the resistance also will changes. This property is used in the measurement of a temperature. The change in the resistance depends upon the materials chosen for the construction of a thermistor. Sometimes we can use the ceramic or sometimes we can use the polymer. Depends upon the construction, resistance also keeps changing. But principle is the same. Whenever the temperature changes, resistance will be changed inside the instrument. Whenever the resistance is changed, the recording or the electrical signal, it will be giving a different number in the output display. We have two types of the thermistors, NTC and PTC. NTC means negative temperature coefficient. When temperature increases, resistance decreases. These type of thermistors used in certain applications. PTC is there, that is positive temperature coefficient. When when temperature increases, resistance also increases. This is the second type of thermistors. Are these the sensors? Yes, it is a sensor. Is it a transducer? Yes, it is a transducer. Why it is a sensor? Because a thermistor senses the temperature and it will be converted to the electrical signal. Is it a transducer? Yes, it is a transducer because heat energy is converted to the electrical energy. We can tell actually both are correct because both are the transducers itself, come into the umbrella of the transducer. It will work in the input side, that's why sensors, I call that as an input transducer. Where do we use it? We use it in fever measuring digital thermometers. First one. Second one, refrigerator temperature control. Battery temperature monitoring in your laptops and in your mobile phones. The third type of the sensor, RTD. RTD stands for resistance temperature detectors. This is also a similar type of a sensor, but it gives a high accuracy. Wherever we need a high accuracy in temperature detecting, we go for this RTD. It usually measures for the wider range of a temperature, starting from minus 270 degrees Celsius to plus 850 degrees Celsius. And it is used in medical field for incubators, industries, highly accurate devices and long life devices. So these are some of the temperature sensors. So if I summarize all these temperature sensors, what is good and what is medium and what is high? If I say accuracy, RTD stands for high when compared to the first two, that is thermistor and the thermometer. Cost is very high in the RTD because accuracy will be very high. If you go for a medium, there stands the thermistor. If it is a lower cost devices, that is the thermometer. Temperature range, it is wider in the thermistors than the RTD and the thermometers. The usage of RTD lies in the industry field. The use of the thermistors will be in the medical and consumer devices. So this is about the summing up of the first type of sensor, temperature sensor. The second type of sensors are the pressure sensors. What do you mean by this pressure? Pressure is nothing but the force applied in one particular area. That is called as a pressure. For detecting, for measuring how much force it is being applied, how much pressure is being applied, we have a wonderful sensors here. Let me take few pressure sensors here. One is a strain gauge and the piezoelectric. Strain gauge is a sensor which measures the strain of an object, and in turn resistance of an object it will be differed, and that is being recorded at the output side. And it is very accurate. Perfect measurements is being taken from the strain gauge. Used in, where do we use it? Used in weighing machines, automobiles, medical industries, like even in BP. While knowing about the blood pressure instruments, we are using this strain gauge. The second type is piezoelectric effect. Second type is piezoelectric sensors. These piezoelectric sensors work in the principle of piezoelectric effect. What do you mean by this piezoelectric effect? You people all will be knowing it. This is one of the oldest experiment what we done in our PU. Whenever tuning fork will be there, whenever we beat the tuning fork, at the particular mechanical vibration, the sound is produced, and that sound is being converted to the electrical signal. That sound energy is being converted to the electrical energy. The same concept we are using in this piezoelectric sensor. And the sensor generates electric voltage when pressure is applied on that. Some of the few examples of the piezoelectric sensors are car airbags, where a human body is been accidentally, if it hits on the steering, that pressure is converted to opening up of the airbag in the vehicle. That is, pressure is being converted to the mechanical energy, and that saves many of the human lives in the car. And the second one, heartbeat pulse sensors, earthquake detections are the most common examples of the piezoelectric sensors. As a conclusion, I can say, what is the difference between where do we use the strain gauge sensors and where do we use the piezoelectric sensors? Strain gauge sensors, it will be used for static force, where the force is fixed. It is been used for weight, for detecting weight, for detecting force, for detecting load. These are all the static force. The next sensor is the motion or the proximity sensor. What is this? And which are the sensors are we using it? Let's go for this. Motion or proximity sensors, these are the sensors used to detect the presence of an object, movement of an object and the distance of an object from the source without any physical contact. Understand? We have two types of the proximity sensors. One is IR sensor, the second one is ultrasonic sensors. What are these IR sensors? IR sensor is based on the principle of the working of the infrared rays. The IR sensor sends the IR rays and whenever it hits on the object, it reflects back in a speed. And that speed, it will calculate the distance of an object from the source. This is the principle behind the IR sensor. We have two types of IR sensor. One is the active IR sensor, which will detect the obstacles. Second one, the passive IR sensor, or it is most commonly used as PIR sensors, which detects only the human body. Let me take an example. We have one hall where we need to calculate the number of people who have entered there. We have to detect only the human objects because sometimes even we can move the machines also. For example, the sound systems. The sound system movement also it will be calculated as +1. But that is to be neglected. So at the time what do we have to do? To detect only the presence and the number of the human bodies, we go for PIR sensors. That is the main criteria for using the PIR sensors. Where do we use it? Mall entrances, automatic lights, example, smart home systems. Best example. There we use the IR sensors for movement of the objects, movement of the human bodies. The second one, ultrasonic sensors. The same type of working what is going for the IR sensors, we are using the same here in the ultrasonic sensor. But there we are using the IR sensors, we are IR rays to send the objects, to send the waves, but here we are using the ultrasound waves. We send the ultrasound waves and the time it hit the object and return back, that will be calculated for the distance calculation from the source. There in IR sensors, light waves are sent and it reflected back for the calculation of distance of the object. In ultrasonic waves, we send the sound waves for calculation of the object. Example for the ultrasonic sensor, reverse parking sensors. In the cars, water level detection in the water tanks. Now let me summarize where do we use the IR sensors and where do we use the ultrasonic sensors. Range is very short in the IR sensors, but very large range it will be there for the ultrasonic sensors. Output will be digital or analog can be happening in the IR sensor, but in ultrasonic sensors we have only the digital, and cost is less comparatively in the IR sensor than the ultrasonic sensor. And here detection of light happens in the IR sensor, detection of sound can happen in the ultrasonic sensors. Which works in the dark here? Of course it is the ultrasonic sensors. Even in the dark mode, only one sensor which is used for detection of the objects, that we go for the ultrasonic sensor, but IR sensor works only in the presence of the light. After completing about the motion or the proximity sensors, we go for the biomedical sensors. These biomedical sensors are the specialized sensor which is used to detect the physiological parameters of the human body. What are the physiological parameters such as heart rate, oxygen level, blood pressure level, and we have the brain signal level calculation. For all these we go for the biomedical sensors, and these are used in hospitals, telemedicines and also in the diagnostic centers. Here I took the ECG electrodes and the pulse oximeter sensors as an example what we use in biomedical sensor. ECG electrode, or it is also called as electrocardiogram sensors. We don't know one minute thing what happens in our heart. Our heart, it will generates a biomedical, or we can also say it is a bioelectrical signal which will be produced by the heart, which is in millivolts range, very small volts range. And the electrodes what is being used in the ECG, it will picks up, it will catches these signals, amplifies this signal, and it will be recorded in the record sheet. What we see the fluctuations in the ECG, that is nothing but that is the electrical signals produced by the heart, but that is been amplified version, that's all. Who is all doing here? ECG sensors, ECG electrode sensors typically to say. And next one is the pulse oximeter sensor. Pulse oximeter sensor measures oxygen saturation in the blood, heart rate of the body. Where do we use all these sensors? We all know that this is not a new one, we are not actually using, we can't say that. These are all used in hospitals, fit bands, telemedicines. So these are all the few examples of the biomedical sensor. And the last one what I have listed here is a gas sensor. Gas sensors detect the pressure and concentration of gases in the environment. First one is a LPG sensor. The LPG sensor is used to detect if any change in the concentration of the LPG, liquid petroleum gas. It is used in the kitchen gas alarms, auto shut-off gas supply in the smart homes. The models used in the gas sensors is MQ2 and MQ6. The other sensor used for gas detection is carbon dioxide sensor, which measures the concentration of the carbon dioxide in the air. Examples: industry air quality, artificial respiration. The models used as a carbon dioxide sensors are MG811. So these are all the few types of sensors what I have listed. Let me go for the real-time application of all these sensors, where I will tell you which are the sensor and how are we using it. The first real-time application I am taking here is the smart home application. Guys, just imagine your home which will be turned on the lights based upon your presence, and the fans will turn on and turn off, and even the speed is variation depending upon the temperature of the environment, and the doors are open automatic, on and off, open and the close based on the face detection, and that too face detection of the familiar people. It is possible? Yes, due to the smart home applications in IoT. A smart home is a combination of home automation with the IoT technology, controlled using the mobile apps or the voices or the sensors mainly, saves energy and increases the security, enhances comfort and the security. Which are the real examples on the smart home application? Alexa or the Google Home, smart AC and the smart fans, gas leak detection, face-based door unlock and locking systems. Now we go for few real-time applications of the sensors and actuators. However, it is a transducers. The first real-time application we are going for the understanding of the smart home applications. This is a block diagram of the entire working of the smart home system. The sensors, it will detect the physical parameters, and the electrical signal what is generated at the sensors is being given to the microcontroller. Here we are using the microcontroller ESP232 or the Arduino, and here the programming will happen, process the data, and the output will be given to the mobile app or the actuators like fans, lights, motor vehicles. And before sending to the destination, first it has to be communicated properly over the wired or the wireless communication. That happens through Wi-Fi or the MQTT model. And the data, whatever we are sensing it and we are processing it, it has to be saved in the cloud, which is done by the cloud server, and then it reaches the destination. This is the entire flow of the working of the smart home applications. And here I have listed some of the sensors and its purposes which is being used in the smart home, because we all know about the smart home application, but for which sensors, what are the application? For phase detection, what are the sensors? For temperature and humidity in the fan, which are the sensors we are using it? Here we have a list. PIR sensor, we are using it in the motion detection. That is if any of the object is being moved or object presence or absence is being detected, will be done by the PIR sensor. DHT11 and the DHT22 are the two temperature sensor used to detect temperature and humidity, and it will be given to either automatic fans, automatic air conditioners. MQ2 and MQ5, these are the sensor used to detect LPG gas. LDR, light detection radiation. This is a sensor used for smart light control. Whenever you enter, light will be on. Whenever you are going out of the room, the light will be off. That will be done by LDR sensor. And one more is a ultrasonic sensor used for security purpose, and also to understand what is the distance of the object from the source. The last, we are using camera with AI for face detection. These are all the sensors, what I told in the starting, we are using in smart home applications. The next real-time application what am I taking is biomedical applications. Students, during the COVID times, just imagine how the world was. During COVID times, many patients were monitored at homes itself. Their oxygen level, body temperature, heart rate were sent live to the doctors, and medicines were given in the online system. This saved millions of people. How did it work? This is due to the biomedical applications using the IoT. Then what is biomedical applications in the IoT? IoT in the healthcare system, which was smart monitored and treated properly using the online or the internet, is called as biomedical applications in the IoT. What are the key things we have to understand in the biomedical applications? It remotely monitored the patients. AI-based early diagnosis was made. Smart hospitals and ICUs came into the picture during the COVID times, which has a technology of the IoT. Wearable biomedical devices were due to the working of the IoT. Telemedicine is gradually and exponentially it is being improved by the understanding, applying of the IoT. Technology that saves lives is due to the IoT, sensors and actuators, and that is called as the transducers. And which are the sensors are we using in the biomedical applications? Here is a list. ECG electrodes is used for heartbeat monitoring, pulse oximeter for the understanding for detection of the oxygen level and pulse, BP sensors for detecting the blood pressure control, temperature sensors for the fever detection, glucose sensors for the diabetic monitoring, EMG sensor for muscle act. These are the main sensors used for biomedical applications, and everyone we are using all these till today.
Das ist der Nest-Thermostat von Google. Es handelt sich um einen intelligenten Thermostat, mit dem Sie Energie sparen können, wodurch Sie Geld bei Ihrer Stromrechnung sparen. Und mit all den Einsparungen beim Heizen und Kühlen ist der Austausch Ihres alten Thermostats fast ein Kinderspiel. Sie denken sich wahrscheinlich, oh, wow, aber wie? Nun, dieser Thermostat kann Ihnen helfen, einen Energiesparplan zu erstellen und ihn dann automatisch anzupassen, damit Sie keine Energie verschwenden, wenn Sie nicht da sind. Sie müssen nur Ihre Einstellungen auswählen, Z, B, die Temperatur, die Sie für Ihre Anwesenheit, Schlafenszeit oder Abwesenheit wünschen, und dann Ihren Zeitplan eingeben. Wissen Sie, was noch cool ist? Der Nest-Thermostat ist eine Art Energiesparberater. Er kann Ihnen helfen, Möglichkeiten zu finden, um weniger Energie zu verbrauchen. Er kann Ihnen beispielsweise einen Vorschlag senden, Ihre Schlaftemperatureinstellungen zu optimieren, damit Sie beim Schlummern Energie sparen können. Er kann Ihnen auch helfen, Ihre Heiz- und Kühlanlage im Auge zu behalten und Ihnen nützliche Erinnerungen zu senden. ZB, wenn Sie einen Filter wechseln müssen. Das Gerät kann dich sogar warnen, wenn etwas nicht stimmt, und dir dabei helfen, einen qualifizierten Fachmann für eine Systemprüfung oder Reparatur zu finden, damit alles wieder funktioniert und du dich wieder deinem Leben widmen kannst. Angenommen, du bist im Park und möchtest nach Hause kommen und ein perfekt kühles Zuhause vorfinden. Dann kannst du die Google Home App öffnen und dich darum kümmern. Du kannst den Thermostat auch über deinen Nest-Lautsprecher steuern. Hey Google, erhöhe die Temperatur. Vielleicht denkst du dir, ist das wirklich teuer? Nun, Das ist es tatsächlich nicht. Mit Rabatten von deinem Energieversorger kannst du es sogar noch günstiger bekommen. Und wenn du deine H1-Anforderungen gerne selbst erledigst, ist der Nest-Thermostat so konzipiert, dass du ihn selbst installieren kannst, sodass du niemanden dafür beauftragen musst. Wenn du möchtest, kannst du ihn aber auch von einem Fachmann installieren lassen. Auf diese Weise kannst du mit dem Nest-Thermostat von Google Energie und Geld sparen.
And these are the use cases in the biomedical application. We are using the wearable health as a smartwatch and the Fitband. ICU monitoring in the form of ECG and oxygen level detection. Telemedicine, this is one industry where we are using the technology doctor from the home under the IoT. Emergency, for example, fall detection alert that is being given using the sensors to the nearby hospitals, and ambulance reaches to the most emergency. The last one is a smart ambulance, what did I say now, for the live data transfer of the patients who has fallen sick and also who has gone through the accidents on the roads. These are the real life use cases in the biomedical applications. Emergency alerts will be given to the nearby hospitals for the life-saving applications. This is the wonderful discovery of the IoT under the biomedical applications. Coming to the last real-time application, that is the automotive applications in IoT, where Industry 4.0 starts, where smart cars will be used, where we are using the automatic traffic light sensing. What is happening in our daily life? What is IoT in automobiles? IoT in vehicle enables real-time data collection, smart decision making, safety assistance, remote monitoring and diagnosis. Everyone know about the Tesla car. This is the best real-time case study for the automotive application, which uses radars, ultrasonic sensors and cameras for the better understanding and working of the Tesla cars, which enables semi-autonomous driving features. Not only the Tesla cars, driverless cars is happening today due to the IoT applications. These are the future trends in the IoT: sensors using, actuators using, transducer using in the different examples. Future trends here: smart cities, which gives a large scale IoT sensor network, our Industry 4.0, which uses cyber physical systems, biomedical wearables for the continuous health monitoring, autonomous vehicles for sensor fusion technologies. These are the future trends. And where do we have career opportunities after understanding about the IoT, sensors and the transducers? We have an enormous job opportunities in embedded system design, IoT development, biomedical engineering, robotics and automation industries, automotive electronics. Overall, today we are all growing in the applications of semiconductor technology, where all the semiconductors are designing for the IoT applications. We have future, guys. Not only about the job opportunities. Being diploma students, you people will be understanding about the topics which is already there at the syllabus of the B level. You people will be having IoT as a core subject, robotics as a core subject, embedded system as a core subject in the B. To understand those things better, today these concepts becoming a foundation course for those subjects. Thank you.
ಭವಿಷ್ಯದ ತಂತ್ರಜ್ಞಾನದ ರೂವಾರಿ GTTC